Okay, to deal with the Michelson parameter for determination for the Michelson parameter Vmax and Km, we said that we either do it for single dose or multiple doses. So we will start with the single dose determination, in which we will use what we call it Line-Weaver-Burke equation or a plot. Okay, if you look at your slides, you'll find that Line-Weaver equation is multiplied to 1 over the concentration of the drug plus 1 Vmax. Okay, this is the equation that is called Line-Weaver equation, in which we can use it to determine single dose Km and Vmax if we are talking about nonlinear kinetic. Okay, if you look at the equation, you can find that if we have this versus this, then we are talking about linear kinetic, or linear, sorry, not linear kinetic, linear equation. Okay, and it's just a result of the reciprocal of Michelson equation. So the equation that we already have, in which it's Vmax, okay, we just took the reciprocal of it, okay, and rearrange it to have this. Okay, the line, why we did that, when you find the or you try to plot the Line-Weaver plot, okay, which will have 1 over V. Again, you have it on your slide. You will have this profile with x-axis intercept with y-axis intercept, and for sure you will have slope for that. So if you have different data sets, or different 1 over V versus 1 over the concentration, you can determine the slope by having the linear equation, okay, of it, and you can find that this, according to this equation, will be the intercept, the y-intercept, which is 1 over Vmax, right? This is y, this is a, this is x plus b. Okay, so you will have 1 over Vmax, so you can determine Vmax, and from the slope of the equation, you will have Km over Vmax. If you determine Vmax, you will be able to determine Km. So the idea of having the reciprocal of the equation of Michelson equation to get a linear equation, so you can deal with that easier than when you have the Michelson equation. So we have the slope, we have the y-intercept, and just try to find what will be the x-intercept to determine the parameter. You will have Km in here, but what is the x-intercept? Just try to have it and see what will be the answer. Okay, after that, here we have the rate, the reciprocal of rate versus the reciprocal of the concentration of the drug. But usually in practice, we have concentration versus time. So what we will have practically, what you will have, or what usually what you will encounter, that we determine the change in concentration versus time, usually for at least 2 points. So we have 2 points in the profile that we have here. So we have the change in the concentration versus time by taking the change in concentration over the change in time, that will be equal to difference between different concentration over the difference between the time that we are talking about. Okay, so you will have change and the concentration versus time. Okay, as mass over volume versus time. Then take the average. This is the first thing that you will do. Then take the average concentration or the mid-time concentration. So you have different way of representing it, mid-time or just concentration mid, which will be equal to the concentration, let's say, equals to concentration first, concentration 1 over 2, just the average of it. Or if you having 1 and 2, 1 and 2. Okay, then what we will have the same as Michaelis-Menten equation, the practical expression of it, rather than having rate. This is the original that you have. Rate V max, dose, concentration. I keep saying as dose because it's the Km. No, this is plus concentration of the drug. Okay, so rather than just saying it's concentration, this will be your average concentration, and this will be your average concentration, and this will be the change and the concentration over time. Okay, when you have the line weaver, the same thing. This is the red one is the practical expression of Michaelis-Menten equation. So you have only to have 2 points usually measured in line weaver Berg equation of it. Again, it should be 1 over, or what we call it, the average, okay, that we have, or the change in it, okay, which will be equal to Km. See here, it was Km over V max multiplied to 1 over time plus 1 over V max. So the same thing that you have, but we have C difference, which is this one, mid-time point, and this, which is this one. So you have the change, delta Cb versus delta T, to have it as rate and change. It will be mass volume per time, right? Okay, so change versus time, but in terms of concentration, and this will be mid concentration point. Okay, then the same thing as equation. When we have the Lineweaver plot, you will have rather than 1 over V, and here 1 over concentration will be 1 over this, right, versus time, but still the profile will be the same. You will have 1 over V max, you will have Km over V max as a slope, and you will have the same x-intercept that we have it already. Okay, so the idea of this is just the way that we can deal with it practically, so we can decrease the number of experiments that we need to do, or number of samples that we need to acquire for the experiment. Okay, this is how you deal with the single dose kinetic. Okay.